The Sonodur 3 is a portable hardness tester designed to evaluate metallic materials, particularly after heat treatments or surface machining processes. This verification is essential to ensure the final product meets the required quality and technical standards. Its compact and rugged design makes it ideal for use in hard-to-reach areas and confined spaces, enabling reliable measurements directly on weld seams, adjacent zones, and heat-affected areas. One of its most notable features is the ability to perform layer hardness testing with multiple measurement points. The system delivers accurate and repeatable results, even on fine-grained homogeneous materials, making it highly reliable across a wide range of industrial applications. The Sonodur 3 operates on an Android-based system, enabling seamless data transfer via Bluetooth, SD memory card, and USB cable. With virtually unlimited storage capacity using SD cards, the device ensures efficient handling of inspection data. Additionally, inspection results can be sent directly via email from the device, streamlining reporting and communication in the field. The Sonodur 3 is also designed to be compatible with a wide range of manual and motorized probes. The manual probes are available in various specialized configurations, including long and slim variants, and cover a force range from 1 Newton to 100 Newtons, equivalent to approximately 0.100 kilograms force to 10 kilograms force. The system also supports motorized probes, designed for consistent and automated measurements. These probes range from 1 Newton to 8.6 Newtons, equivalent to approximately 0.100 kilograms force to 0.900 kilogram force, making them ideal for applications that require controlled and repeatable force during hardness testing. The Sonodur 3 is designed for adaptability. Depending on the application, whether testing thin materials, large components, or parts with complex geometries, the available probes can be selected and configured accordingly. It also supports multiple hardness testing methods, including UCI and LEAB techniques. This allows the user to switch between UCI probes and LEAB-type probes, depending on the application. LEAB probes are particularly well suited for large or heavy components and heat-treated materials. The reference scale for LEAB testing follows the Becker's 10 standard, in accordance with ISO 16859. The Sonodur 3 also sets the standard for UCI hardness testers, serving as the successor to the MIC-10 and MIC-20 series. It complies with major international standards, including ASTM E1038, DIN 50159, ASTM E140-13, and ISO 18265 for hardness scale conversions. The system includes standardization controls accessible through the interface. These allow the user to perform 5 reference readings and adjust calibration settings based on certified hardness reference blocks. The Sonodur 3 offers an impressive measurement range, from soft aluminum approximately 20 Brinell to extremely hard metals, up to 1600 Beckers, depending on the material and probe used. Powered by Android 7.0, the device offers up to 10 hours of battery life. It comes with a dedicated charging base, an IP65 protection rating, and weighs approximately 320 grams. Next, we will do the basic setup. Before turning on the Sonodur 3, the first step is to connect the sensor using the supplied cable. This cable includes a filter with a directional arrow. It's important to make sure that the arrow is pointing toward the device, not the sensor. Both the device and the cable connector have a half-moon shaped notch. These notches should face opposite directions when connecting. Gently press the connector into place until you hear a click, indicating a secure connection. Repeat the same process at the other end of the cable to connect the sensor. Again, align the notches, press firmly, and listen for the click. Once everything is connected, you can power on the device. On the side of the unit, you'll find the power button. Press and hold it for about 3 seconds, then release. The Sonodur 3 will turn on. Right next to the power button, there's a protective cover that shields both the charging port and the data transfer port. In this case is a Type micro USB. Just above that is a button labeled FN. This button isn't assigned to any specific function by default, but you can configure it through the system settings to perform a task of your choice. On the back of the device, there are two sliding latches that allow you to remove the battery easily. There are also anchor points on either side for attaching a 2-point carrying strap, making the device more secure when used in the field. At the top right, you'll find the built-in camera and flash, which are useful for capturing inspection environments or documenting results. On the front of the Sonodur 3, there's a 5-inch touchscreen display that provides clear visuals and easy interaction. Right above the screen, you'll find LED indicators showing whether the device is charging and whether power-saving mode is active. At the very bottom of the device, there are 4 physical buttons, each with a specific function. The left button takes you back to the main menu. The circle button opens the home screen. The square button shows recent applications or screens. And the FN button, as mentioned, can be customized to suit your workflow. These are the key display and control features of the Sonodur 3, designed to be user-friendly, efficient, and reliable. To ensure accurate hardness measurements, it's essential to perform a proper standardization procedure. Remember that it's always important to verify the accuracy of your measurements by comparing them against a certified reference block with a known hardness value. Begin by selecting the appropriate hardness scale that matches the reference block you're using. For this example, our block is marked 58 Rockwell C plus or minus 2. Then the acceptable range will be between 56 and 60 Rockwell C. Once the scale is selected, hold the sensor properly using one hand. Use the other hand to guide the sensor vertically, ensuring it contacts the surface at a 90-degree angle. Apply steady pressure until the measurement is displayed on the screen. After each reading, the device will display both S, the current measurement, X, the running average. Take at least 5 readings on the reference block as recommended by ASTM E140, which specifies that a minimum of 5 consistent measurements should be used to validate accuracy. Be sure to place each reading on a clean area of the block, avoiding any previous indentations. If the values fall within tolerance, the sensor is properly standardized. While taking readings, the system also displays a color-coded time bar. Green indicates correct contact time. Red suggests that the reading was taken too quickly or too slowly. For the most accurate results, only accept measurements when the bar is green. If the time bar is red, repeat the reading with better timing. If the average is consistently off from the block's certified value, use the evaluation adjustment function from the calibration menu. Confirm you'd like to use your readings for adjustment. Input the certified reference value. Finally, save the adjustment. The device will now display a correction factor on screen, in this case, -102. You can save this calibration profile with a custom name, so it can be reloaded later without redoing the process. To ensure consistent results, always clean the test surface. Avoid remeasuring on previous indentations, and recheck the reference block if readings drift over time. Once standardization is complete, your device is ready for in-field measurements. Motorized sensor standardization. When using a motorized UCI sensor, the standardization process is simpler and more consistent thanks to its automatic operation. Before anything else, connect the sensor to the Sonodur 3. These sensors typically apply test forces of 0.1 kilogram force, 0.3 kilogram force, or 0.9 kilogram force. The latter is equivalent to approximately 1 Newton. To begin, open the UCI app on the Sonodur 3. With motorized sensors, we need to talk about the dwell time setting. This one applies only to motorized sensors. It defines how long the diamond tip remains in contact with the surface under load. The default is usually set to 5 seconds, but can be adjusted to suit different inspection needs. This setting ensures consistency in how the measurement is applied across different tests. You can adjust as needed. As with manual probes, ensure you're using the correct hardness scale and a clean, unmarked surface on your reference block, and take at least 5 readings across the block. If the average falls outside the acceptable tolerance range, perform a calibration. Place the motorized sensor gently on the reference block's surface. The system will automatically detect the sensor and prepare to take a measurement once the probe touches the surface. When contact is made, the diamond indenter is automatically lowered, and the dwell time countdown begins. You can adjust the dwell time in the settings depending on your inspection requirements. Remember, this feature is only available for motorized sensors. It remains disabled for manual or rebound sensors. Next, in evaluation adjustment, accept the use of the latest readings. Input the certified block value, in this case 56.7 Rockwell C. Confirm and save the adjustment. The system will generate a calibration offset, visible as a numerical tag, for us as negative 344 on screen. You can store this setting with any name you like. Motorized sensors provide very repeatable results due to consistent force, pressure, and perpendicular contact, making them ideal for production or critical testing environments. To ensure measurement accuracy, do not move or lift the sensor during measurement. Wait until the arrow icon on screen disappears before removing the probe. Always inspect and clean the contact surface. Handle the diamond tip with extreme care. It is delicate and can be easily damaged if dropped or pressed against hard surfaces without control. Avoid touching it directly and never store the sensor without its protective cover. Once saved, you can reload this standardization profile at any time via calibration, then load adjustment. This eliminates the need to recalibrate for each session. Leap sensor calibration via Bluetooth. The Sonodur 3 also supports lead-type rebound sensors, which are ideal for testing large parts and coarse-grained materials. These sensors connect wirelessly to the device via Bluetooth. To begin, remove the protective cap from the sensor tip. If necessary, use the provided soft bristle brush to gently clean the impact body inside the sensor. Reassemble the sensor and leave the cap off for testing. Leap sensors operate using a rebound method based on electromagnetic induction. Inside the sensor is a small impact body, a magnetized metal mass guided within a tubular shaft. Next, activate the Bluetooth feature on the Sonodur 3 and power on the Leap sensor by holding its button for 3 seconds. The sensor's LED will indicate that it is powered on. Then, launch the LEAB application on the Sonodur 3. Tap to initiate pairing. The device will automatically detect and display the sensor's serial number. Once connected, you'll see both LEAB method and Bluetooth indicators appear on screen. For standardization, select the correct hardness scale. Use a large reference block appropriate for LEAB testing. Place the sensor on the surface, press the release button, and the impact body will strike the material. The device measures both the impact and rebound velocity to calculate hardness. Take 5 readings, then go to calibration, and then to evaluation adjustment. Accept the recent measurements. Input the certified hardness value. We'll do 110 Vickers. Confirm and save. A calibration offset of -434 will be applied. You can save this profile under a custom name. Remember, always clean and inspect the sensor tip. Never test over existing indentations. Use Bluetooth only after verifying proper pairing. Once testing is complete, Sonodur 3 allows you to export all test data for reporting and documentation. To export results, press the exit button. If you've taken any readings, the system will prompt you to save your session. You can name the file any name you like to keep test sessions organized. All saved data is stored internally in the device's storage, in a folder named Sonodur, then the data directory. Files are saved in .txt format, making them easy to open in Excel or transfer to external databases. Each exported file includes file name and timestamp, operator name, sensor type and serial number, hardness method and scale, certified standard used, number of readings, max, minimum average values, CP and CPK statistical values, if applicable, and any comments added during the session. Finally, you can transfer files via USB cable, NFC near-field communication for quick mobile or tablet sharing, direct email from the device if the email function is enabled in whitelist settings. This data export process ensures a complete and traceable record of your hardness testing procedure, ideal for certification, audits, or internal quality control. Thanks for watching. If you found this helpful, please like and share it with others. Don't forget to follow us on social media and subscribe to our email list to learn more about NDT and gain the skills that set top inspectors apart. See you in the next time.